Okay, for lesson 10.3, we're talking more about arcs and chords. So, a chord is a segment with endpoints on a circle. We talked about that before. Switch colors in the middle here. On a circle. But what if we place another chord in the circle that is congruent to the first chord? So if we look at our picture here, I'm going to attempt to draw two congruent chords. So bear with me here because I'm on my iPad. So I'm going to say that that's 3 centimeters. And you guys can actually measure it out on your paper. So do 3 centimeters. I'm going to call that CD. And then I'm going to attempt to draw 3 centimeters again over here. So you just have to line up 3 centimeters and make sure the endpoints lie in the circle when you're measuring it. So I'm going to call that A and B. And so I can go like this and show that the arc lengths are congruent. So that means that the chords in the central angle would also be congruent. So if I've got two congruent chords, so if arc AB, nope, sorry, not arc. If line segment AB is congruent to line segment CD, so those are two chords, which are line segments, then, like I just said, that also means that their arc lengths are congruent. So notice that I'm doing arc length, which when we talk about, not arc length, I'm talking about the actual arc itself. AB is congruent to the actual arc itself, CD. So again, this is talking about, just like we talked about before, when we've got the line over it, we're talking about the actual figure, not the measure of it, or not the length of it. So same thing here, we're talking about the actual physical object, the physical figure, the arc. So the arcs are congruent. So if the chords are congruent, two chords are congruent, their arcs are congruent, which again then means that their measures are equal. So the if you looked at the length congruent here, then the measures of the arcs would be congruent as well. So we can also say the other way. So if I actually knew that the arc AB was congruent to arc CD, then I would know that chords AB were congruent. Chord AB is congruent to chord CD. So you guys know that if we can say it the same back as forwards, we've got an if and only if statement. So arc AB is congruent to arc CD if and only if chord AB is congruent to chord CD. And you can say line segment, well, we know it's a chord, so we're going to say chord. So the above is also true for two congruent circles. So if we have congruent circles and we have congruent arcs or congruent chords in two different circles, but we knew the circles were congruent, then these would also apply. Okay, if a diameter or radius intersects a chord perpendicularly, so we're going to abbreviate a little bit here since there's not a lot of room, so perpendicularly, just put a little "ly" on there, then it also bisects the chord and its arc. So if a diameter or radius intersects a chord perpendicularly, then it's a perpendicular bisector. So say we've got a chord right here, and again, bear with me here. So there's my chord, and say it intersects perpendicularly, then it also bisects that chord. And so we would know that not only that those two congruent, the two segments that it's split into, but it also splits the actual arc lengths and the measure of the arcs. It bisects those as well. If a line perpendicularly bisects a chord, so a line perpendicularly bisects a chord, then the line contains the diameter, radius, and center. Okay, so say I've got a chord, just a random chord, and it gets bisected. So I'm going to attempt to bisect this here. Okay, that's a little off, but human error. Then that line that actually bisects it, so this is, going to be a line, it goes through, it is a diameter, so those two endpoints will form a diameter, and it goes through the center of the circle. And I'm doing my best to mark the center here. So if I know a line perpendicularly bisects a chord, then it must go through a diameter and the center of the circle. So I can do another. So again, bear with me with my not straight chords and not bisecting. It will be really, if you guys actually bisected, you guys should actually do that. Actually bisect these, measure it, and make sure it hits perpendicularly, and you should go through the center of the circle. It'll be a lot more accurate than what I'm currently doing. And then, so if I try to bisect this, I should just measure it anyway. I don't know where my measuring tool is, so we're just going to keep going with winging it. All right, so we're going to say, oh, that looks great. We'll try one more time. So this is not even necessarily the center, but it looks good. So really, if you measure it and make sure it perpendicularly bisects it, it should be fine. All right, so that bisects perpendicularly, so that line that I just drew has to go through the center, which it does, and it has to, since it goes through the center, obviously it's going to be a diameter because it will go through the side of the circle twice, so it'll have endpoints. You can form a diameter. And obviously if it goes through the diameter, it goes through the radius. So, okay, next one. So congruent chords are equidistant from the center. So if you have two chords that are the same length, then they're going to be the same distance from the center. So those are my two congruent chords. And I want you guys to actually measure, okay? And remember, distance, when we're talking about distance here, it's got to be perpendicular. Okay? So I want you to use your ruler or your protractor and make sure it's perpendicular from, and it'll actually be, if we look at it'll be the bisector actually, to the center. So it'll be where, cut this in half, okay, the midpoint, make sure it's perpendicular and to the center. Okay, so again, I'm going to just attempt, that's pretty good. So we're going to say that's a right angle, and then if you measure that, it will be the same. And I want you guys to actually measure it. I'm just not doing it since I'm on the computer. Okay, and those should be the same. And again, the reason it's going to be the actual midpoint of these lines is just because of this fact right here, that when you perpendicularly bisect a chord, the line through it will go through the center. So to get to the center and be perpendicular to this chord, it's going to be at the midpoint. Okay, so let's look at your homework. Let's see if I'm going to do any of these. Let's look at number 8. So I've got the measure of an arc, so I know that the measure of arc FG is equal to 70 degrees. And I've got a congruent arc over here because it's marked that way. So I also know that the measure of arc HJ is 70 degrees. So that's it for that one. So, well, X is equal to 70. So you can think of it as congruent chords, that's supposed to be congruent sign, cut off congruent arcs, which makes sense. All right, let's look at number 10 now. So on number 10, we've got the measure of arc WY is 143 degrees. Okay, and then if you look at it, these two arcs are congruent because their lengths are the same. So they have, both are 18. So I know that the measure of arc WY is going to be equal to the measure of arc YZ because their arcs are congruent. So I know that arc WY is congruent to arc YZ. So that means that their arc measures are going to be the same. So I can set those equal to each other. So I know that 143 is equal to 2x minus 1, and I can easily solve for x. So I know that 144 is equal to 2x divided by 2 and 72. So x is equal to 72 for this one. Let's go ahead and look at the next page. Okay, so we're going to look at number 22. Oops. So in circle F, AB is congruent to BC. So AB and BC are both chords, so they're congruent chords. DF is equal to 3x minus 7, and notice that DF is the distance between the chord and the center. And then EF is x plus 9, and that also is the distance from the chord BC to the center. Since the chords are congruent, the distance from the chords to the center is the same. So we know that 3x minus 7 is equal to x plus 9, and I'll let you finish that one out. Now we're going to look at number 27. Oh, here, I'll put a little note here. So remember that congruent chords are equidistant from the center. Okay, let's look at number 27. In the logo, each chord is equal in length. What is the measure of each arc and the length of each chord? Okay, so I know that all these chords are equal. So that means it's a square. So if we draw a diameter, okay, so it is going to bisect those angles, okay? So we know that that's going to form a 45, 45, 90 degree triangle, which we know some cool things about. So that's a right angle mark. That looks terrible. All right, so right angle mark, and then whoop, whoop. Okay, so 45 degrees each. So we know that that is side length x and x, and they tell us that the diameter is 3 feet. So if I know the hypotenuse of a 45, 45, 90 degree triangle, I know I get that by taking one of the side lengths times square root of 2. So I need to take 3 divided by the square root of 2 to find the side length. Rationalize by multiplying by square root of 2 over square root of 2, and you get 3 square root of 2 over 4. I mean the square root of 4, which is 2. So let me just erase that right now. So square root of 2 times square root of 2, which is 2. Okay, so 3 square root of 2 over 2. That is the length of the chord. So, and it's in feet. So that is what x is equal to, since we called it x. Okay, that's it for that one. Now we can look a little bit at 33. So we got two major arcs here. We know that WTY is congruent to TWY, and we are trying to solve for x. So if we look at the chords here, WTY is this guy, and TWY is this guy. And we know they're congruent. So TWY consists of TW, arc TW, and arc WY. So if we look at their measures, that will equal the measure of arc TWY. So we know the measure of arc TW is x, and the measure of arc WY is 2x plus 10. and that's going to be the measure of arc TWY. And then if we look at the other guy, WTY, we know that that consists of the measure of arc WT, which is the same as the measure of arc TW, plus the measure of arc TY. So that equals the measure of arc WTY. And we know the measure of arc WT, same as TW, is equal to x, plus the measure of arc TY, which is 4x, is equal to the measure of arc WTY. This is a mouthful. All right, and then, so since they're congruent, we know that their measures are equal. So right here, we know that this statement right here and this statement right here, use the transitive property here. Since these are the same, then these two must be equal. So I know that x plus 2x plus 10 is equal to x plus 4x. And really, since they both share this, it's really unnecessary to even look at that, I guess. So we can just, could have done just 2x plus 10 equals 4x. Either way, it works. So go ahead and solve that, and you should be good with the rest of them.